finding all roots of the polynomial, okay, you want to keep in mind the fundamental theorem of algebra, which you actually already know, you just didn't know that that's what it was called. So officially, the fundamental theorem of algebra tells us every polynomial function of degree n has exactly n roots or zeros. This is exactly what we've been talking about the past few days. Whatever the degree is of the polynomial, that's how many roots that it has, or that's how many zeros that it has. The variable that they use for the degree is n. So like they'll say it's to the nth degree. Okay, so degree n means there are n roots. Keep in mind that this includes multiplicities as well as real and complex zeros. Okay, so there are real zeros that we know are on the x-intercept, which are the x-intercepts on the x-axis, but there are also complex or imaginary zeros, which remember, you cannot see those on the graph. Okay, so we have to use those methods that we just talked about, okay, like the quadratic formula, you could use completing the square if you wanted, okay, to find the values. So it says know how to explain this. I mean know how to explain the fundamental theorem of algebra. Okay, so the degree, the value of the degree is the same as the number of roots. Okay, so for our next example, example 2, we are going to solve by finding all of the roots. Okay, do you guys need any more time with this part? It just says explain, or know how to explain this. Okay, so know how to say the fundamental theorem of algebra is if a polynomial has degree n, there are n roots. Okay, you can simply say the degree is the same as the roots. Okay, so now we're going to solve by finding all roots. So what I just told you is that you can't just find all roots by looking at the x-intercept. So we're going to have to find some other strategies to solve these polynomials. Yep, x to the 4th minus 3x cubed plus 5x squared minus 27x minus 36 equals 0. Okay, so the first step is to list all the possible zeros, the p over q. Okay, I'm going to show you what I do in a case like this, because it's 36, so it's going to be a lot. I'll make that a little longer. And then the first one is just 1. Okay, so that means when I divide everything by 1, I'm only going to be left with the top numbers anyway, so that's what I'm going to use. And we do like to put these in order. So for 36, okay, 1 goes in there, and you could do 1 times 36. You can just put them at opposite ends. And then 2 goes in there. How many times? 2 times what is 36? 18. 3 goes in there how many times? 12. 4 goes in there how many times? 9. Oh, I gave myself a lot of room. And then the last one is 6. That's the only time I didn't have to scrunch it in there. Now everything divided by 1 is just going to be the top number. So instead of writing all those out again, let's just box in the top. Save ourselves some time. Okay? Alright, now we are going to use the graph to find them. Okay, to find your x-intercepts. Spoiler alert, they're both going to be whole numbers. Okay, and I want you to write those down. And how many are there on this one? So you are going to have to go back to your standard window. Okay, so it crosses here at what value? -1. What's the other one? Yeah. Okay, so there are 2 of them here. I'm going to show you how we're going to use both of them. So we're going to check roots using the synthetic substitution, the synthetic division. And if it is a root, we know that the R value will be 0. So if it is a root, then R equals 0. Nice conditional statement there. Now we are going to continue this process until you get a quadratic expression. So this is going to be a little bit different than what we did on the last page. Okay, so we're going to keep doing it until we get a quadratic. You'll know that you have a quadratic when there are 4 numbers at the bottom, because you'll have the x squared, the x, the number term, the constant, and the remainder. So you'll have like the 1, 2, 3, and then we'll circle the remainder. So it does not matter which one of these you use first. I'm going to use the -1, so if you want to do that with me, that is fine. If you feel like you want to do 4 first, you go ahead and you do that. You will get the same answers no matter what order you go. Okay? So with -1, I'm going to drop down the first, and then I'm going to perform my synthetic division. So 1 times -1 is -1. Add straight down to get -4. Multiply across to get 4. Add straight down to get 9. Multiply by -1 to get -9. Add straight down to get -36. Multiply by -1 to get +36, and a remainder of 0. So what we've just done is we've found that -1 is a 0, just like we've been doing. If you look at your function that is left, though, this has an x to the 3rd power, so this is a cubic function. I cannot do the quadratic formula with a cubic function. But what I can do is I can use these coefficients. I can use these coefficients and perform synthetic division again. Okay, you're just not going to use the remainder. Okay, so notice that I didn't even include it here. Okay, so I'm going to take those values from my cubic function, and I'm going to set up synthetic division again. You have to use these, because if you don't, you're just going to get another cubic function. So I'm going to use 1, -4, 9, and -36. And now I'm going to use my other 0. So because I used -1 here, I'm going to use the 4 for this one. So you already used -1, you won't use it again, you're going to use the other one. So 1 times 4 is 4. -4 plus 4 is 0. Multiply anything by 0, you get 0. Add straight down to get 9. And yay, again we have a 0. Okay, so this means 4 is a 0. So now I have found 2 of my zeros, but I know, according to the fundamental theorem of algebra, there's 2 more I have to find. So this is a number, this is an x, this is an x squared. Okay, so I'm going to set the quadratic function of x squared plus 9 equal to 0, and I'm going to solve that. You can choose how you want to solve it. You can use the quadratic function, but do you have to? The quadratic formula? No. In fact, I would just subtract 9 from both sides. Then you'll get x squared equals -9. What do you do if you have x squared and you want to have x? Take the square root. So when you take the square root, x is going to equal plus or minus what? 3i. Yes, good. Okay, so your roots are -1, 4, positive 3i, and negative 3i. Okay? We are going to finish the last two examples tomorrow. I will post a place for your homework, but it's not going to be due until the next day. Okay?
Maybe the next day or?
So it'll be, tomorrow's Thursday, it'll be Friday. Okay, so how do you know if you found all the roots? So this is something that you've been saying over and over and over again. You know that you found all the roots, okay, if the number of roots is equal to the degree. So if the number of roots is equal to the degree, you have found them all. So we have found 1, 2, 3, 4, and then our degree is 4. X to the 4th is the highest exponent, so we are good. Now, we solve like this. This is going to be the quickest method, but I also want to show you there is an alternate method. Okay, so in some cases, the cubic function is factorable. This does not happen all the time. You do not have to factor it if it's factorable, but some cubic functions can be factored. Okay, so for this one, we had x to the 3rd minus 4x squared plus 9x minus 36. So because there are 4 terms, we can factor using the grouping method. Okay, so if I take out the GCF, x squared, this would be x minus 4. If I take out the GCF here, I'd have 9 times x minus 4. So then I'd have x squared plus 9 times x minus 4. And then what I could do is set each of those equal to 0 and solve. Okay, so if I set x minus 4 equal to 0 and solved, I get x equals 4. That's what we had done in the other synthetic division. And then obviously if I did the x squared plus 9 equals 0, we just did that work up here. We just did that work up here, so we don't have to do it again, but we would get x equals the plus or minus 3i. So you would end up with the same amount of zeros than if you did the synthetic division and then solved this way. Okay, so again, that's just an alternate way you could do it. Some cubic functions can be factored. Not all of them can be factored. Okay, but if you recognize that or if you want to try that, you are welcome to do so.